Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.6, Angle Between Two Planes. So to find the angle between two planes, you first need to know the idea of vector normal, which I've talked about before. Once you've found the vector normal, you would want to use the dot product to find the angle between the two normal vectors. Because the normal vector are always perpendicular to the plane in any direction, which means that the angle between the two vector normals are also the angle between the two planes. Just there's one quirk, which is the angle of the vector normal have a direction. So sometimes you get an obtuse angle, sometimes you get an acute rather. So with that in mind, let's jump into an example and I'll talk about the exact geometry of the two planes. So now we have two planes defined in the Cartesian kind of way. X take 2y plus z equals 5 and 3x plus y equals 1. This looks like just a two variable, but bear in mind, since it's in the 3D space, it has a z factor of 0. So now we can define the normal vector of these two planes. Let's say this is plane A, and I'll say this is plane B. So let's start with plane A. Plane A normal, I will denote normal, I don't need the normal hat, I just need the normal vector, equals to x, remember the Cartesian equation, which is this prefix of the x, y, and z, or the coefficient of the x, y, and z, or the respective vector coefficients. So x is 1, y is minus 2, z is also 1. So we've got this normal vector. Now we go for the B normal as 3 plus 1 and 0. So with this knowledge, we can also say if I have a plane of z equals to 2, which is just a z plane on the value z equals 2, then you will get 0, 0, 2 as the normal. And back then, I recall during some of my past videos that were people asking me, how do I know what is the normal of the horizontal? That's exactly how you do it to derive. Just say that if I go horizontally, I get nothing, no component on the normal vector, then we get 0, 0. Then we have a particular number that you can just fit in. That would be your normal vector of a horizontal plane. But that is not the focus of this video. I'm going to talk about the two angles, the angle between the two planes. So now we have got the two normals. With that said, recall back then when we talked about vector lines and their angle of intersection, we've talked about cosine rule. So let's use cosine rule. Cosine theta, which is the angle between, is equal to A dot B on square root of the or rather, this is a bad way to write it. This is the modulus of A multiplied by the modulus of B. Remember, factors are underlined. So with this, we can rewrite this in terms of A and B, where A is one normal and B is another normal. So let's do the dot product first. Dot product, if you recall how to do the dot product, this is 1 times 3 plus minus 2 times 1 plus 1 times 0, which should give you a positive 1 as a result. And the bottom is the modulus of those two factors. And also, if you remember how to do the modulus of a factor, you should be able to get the square root of 1 squared plus minus 2 all squared plus 1 squared, which should give you 1 plus 4 plus 1 give you 6. Then you multiply that with another modulus of the bottom one, which this time is 3 squared plus 1 squared plus 0 squared, give you a 10. Remember the square root, because there are a lot of people who trip out forgetting that the modulus, when you square all the all the components in quadrature, you get the square of the modulus. So with that said, this is cosine theta, and we can plug that into the calculator using the arc cosine function, and you should get angle of 82.6 degree. This will be indeed an acute angle, because just purely due to the direction that we have chosen to use. If we swapped the normal factor, rather than writing this equation like this, we can state that minus 3x minus y equals to minus 1. It will exactly be the same two planes, except the normal factor now have a negative component, and when you do the dot product, we get minus 3 plus 2 plus 0 give us minus 1 instead. So if this is minus 1, then this angle would turn out to be 180 take 82.6. I didn't actually calculate this, but this will be the let's say this is theta 2. So the obtuse angle will be in this form, and this always holds true if the normal factors are of a different direction. Then it will either give you an acute or an obtuse. So make sure you know what the question is asking for, because a lot of times they will ask you to find the acute angle, but sometimes it's just find the angle. So if it's find the angle without specification, either would work, but if it's specifically said find the acute angle between plane A and plane B, then you would have to actually find this angle that is smaller than 90 degree. So that's all for the example section. So key tips of this whole thing. Normally, when we talk about factors in general, practice finding factor normals of a plane. It's really, really important to actually be able to just look at a Cartesian equation, drag those three numbers down into a factor form. That's the most basic. Make sure you can deal with factor form equation as well, but in this case it would be actually easier if they gave you the factor form, because in the factor form they gave you the normal factor from the get-go. Also, practice your dot products. Do it with intuition. Hopefully by the end of your year, you can look at two factors and just look at them and say this times, well, the first component times the second first component, add second, add third, gives you the dot result, and you should just be able to do that fairly quickly. Finally, the accurate angle thing, very important. I've seen a lot of people losing marks or because they didn't read the question. Make sure reading the question is always the key to success. And it's question time again. Today I've got you 2 questions, both of which is find the angle between. This is just general angle, can be obtuse, can be acute. You tell me, right? It doesn't matter. So I will give you, as usual, 5 seconds, pause the video and get some work done. And I will show you the answer in 5, 4, 3, 2, 1. And the result is shown as above. First question, 109.1 degree. Second question, 59.5. If you found the obtuse angle of either questions, or the inverse rather, because the first question gave you an obtuse angle. If you found the acute angle for the first question, take the answer that is shown from 180 degrees, and you should be able to find the acute equivalent. And same for the second question. With that said, this will be the end of this video. I hope you've learned something. Do let me know in the comment section below if you have any question that you want to clear up, and I will see you on my next one.